Good morning, everyone. Welcome to lesson 2, concept development video. We are actually going to go right into our problem set and do that together today. So go ahead and get your problem set out, get your name on it, and that's what we're going to use as our lesson. We'll do like 1 or 2 problems in each section, then I'll leave the rest for you to practice independently. All right, so, Mrs. Reese, come back. I'll pause my recording. All right, I'm back. Mrs. Reeves wanted to ask what we're doing for math. I said we're doing it all. So I did my practice problem set to make sure I was ready for y'all. So let's go ahead and get our problem sets out. Come on, Miss Briggs, and let's get rolling. All right, let me minimize my face, put my screen down, get my microphone reestablished. All right, so let's zoom in and get our names on it if you haven't already. Let's read the directions. And it says show each expression on a number line and solve. Okay, so let's go ahead and give ourselves a number line, represent 0 and 1 on it. And I better get a smaller pen tool so that I'm not having such a fat line. Well, what's our unit on this one? Well, it's fifths. So let's go ahead and cut 4 lines to create 5 spots. Now, I know it doesn't say it on the directions, but I would really like to see you labeling your fifths. You don't have to put 0 fifths at the first spot, but I really want you to show the whole as a fraction as well. So I have 1/5, 2/5, 3/5, 4/5, and 5/5. Now it wants us to show the expression on the number line of 2/5 plus 1/5. Well, we start at 0, right? We have nothing and we're going to show 2/5. So I'm going to jump with 2/5. Oops, I almost jumped over it. There's my 2/5 jump. Now I'm adding 1/5, and now I'm just going to show adding 1/5. So this is equal to 3/5. Now I know that a lot of us could have done that in our heads, but the purpose of this is not just to make you do extra work that seems tedious, but it's to help you have a conceptual understanding, a visual understanding of what you're really doing with these fractions and these little parts of a whole number. So there is a method to our madness. It's not just to do extra work. So on B, it's 1/3 plus 1/3 plus 1/3. So in my head, I'm saying, I know that answer is 3/3 or 1 whole. So I know that a number line 0 to 1 is plenty. You always cut one less number than your unit. So for thirds, I cut twice. Now let's go ahead and label. And again, you don't have to label the 0, but you do want to label the whole number. Now it's 1/3 plus 1/3 plus 1/3. Here's 1/3, 1/3, 1/3. So our answer is 3/3, which is also equal to 1. Now, if I was to convert this into a multiplication sentence, because multiplication is repeated addition, I see 3 groups of 1/3. Now that's a little extra. I just want you to think about it. Now I'm going to ask you to try these 2 questions on your own. I'm going to pause my video and you're going to go ahead and do it. Now, C, I think you can do perfectly fine, but D looks a little tricky. So one thing I want you to think about when you try this is that we always have to do multiplication first. So I'm going to put that in parentheses to remind me. So I just want you to think about that in the number line. I'm going to go ahead and pause. You go ahead and try to do both of these and then unpause me when you're ready to check. All right, I'm back. I know I didn't finish mine, but I have created my number line. So let's start on C and you can check your work. So I have a 0 to 1 number line. Look at how close those tenths are. It kind of gets a little hard to see those labels. So sometimes it's good to do every other tick mark as your label because we can figure out what that in between tick mark should be based on the marks that you do have. So maybe just do the even marks, maybe just do the odd marks. But either way, it will help kind of clean up the clutterness of the number line. So we start at 0. We're going to go to 3/10. So there's our first jump. And then we got another 3/10, which gives us to 6/10. Another 3/10, which gets us to 9/10. Great. Now this is the one where it was a little different. Now, I gave you the hint of two groups of 3/4. Well, to show, we know that multiplication is repeated addition, so it's just saying that we're adding 3/4 twice, so we can start at 0, go to 3/4, and then that's one group of 3/4, another group of 3/4. So two groups of 3/4 is 6/4, and then one more group is 7/4. So we know that this answer is 7/4. But that's not how we like to leave an answer. We don't like to leave an answer as a fraction greater than a whole, or otherwise known as an improper fraction. So we ask ourselves, how many wholes can we take out of this? Well, we can take one group of 4/4 out of this, so 1, and that would leave us with 3/4 left over. Great job. All right, let's go on to the next part. Now, on this part, it asks us to express each fraction as the sum of 2 or 3 equal fractional parts. So we need to break apart these into having 2 or 3 different addends and write each as a multiplication equation. We'll do the first two together, and then I want you to try the second two on your own. So the question is, can we break on A, can we break 6/7 up into smaller pieces? And we're looking to break it up into either 2 or 3. So we're asking, can we divide 6 by 2 or 3? Well, the answer is we can actually divide it by both. So let's just do the smaller one, or divide by 2. So it would be 3/7 plus 3/7. And let me actually start it accurately. 6/7 equals 3/7 plus 3/7. Now it wants it, the reason why I wanted equal parts is so that we could also show it as a multiplication sentence. Well, how many groups of 3/7 is that? Well, that's 2 groups of 3/7, right? And that is how we stop. We're done. Now let's go ahead and follow those same steps over here on B. Now it's 9/2. The question we got to ask ourselves is, can we divide 9 by 2? Well, no, 9's an odd number, so we can't do that, but we can divide it by 3, and that would be 9/2 is equal to 3/2 plus 3/2 plus 3/2. How much? And those are the same broken apart, 3/2, 3/2, 3/2. So we have 3 groups of 3/2, right? So it's equal to 3 groups of 3/2. All right, I'd like you to try to do the next two on your own. I'm going to pause myself. When you come back, I will have the answers ready. All right, welcome back. Let's just quickly check our work. Now, you can see on C, 12 is a multiple of 2 and 3. So we could break it apart into either way. So we can see 6/10 plus 6/10. We could do it in 2 groups of 6/10, or we could do 4/10 plus 4/10 plus 4/10, which is 3 groups of 4/10. Over on D, we could only do 3 groups of 9/5. All right, let's switch to the next page and see what we got over here. All right, let's read the directions here. And it go ahead and ask us to express each of the following as a sum, so addition, of a whole number and a fraction. So let's do the first two together, and then you can go ahead and try the second two on your own. Now, what this is asking us, basically, is how many, can we rename these as a mixed number using addition, showing addition. So what I want to do is I want to go back to some 4th grade skills of using a number bond and pulling out the wholes. Well, how many wholes can we pull out of 9/7? How many 7/7 can we take out of 9? Well, we can only take 1 7/7, which would leave us with 2 7s. Now I'm just doing that to help my brain. If you can do that in your head, great. You don't have to show the number bond, but I'm just doing that to help you see my thinking. So 9/7 is really equal to 7/7 plus 2 7s. Now we're going to rewrite it because it wanted it as a whole number and a fraction. So 9/7 is really equal to 1 plus 2 7s, which is equal to 1 and 2 7s. So you're just building it apart. You're taking apart the whole, showing it as the whole plus the part, renaming the fraction as the whole number. So now we got 1 plus 2 7s. And then you're just putting those pieces together to the whole, and you show 1 and 2 7s. Let's try that together with B. And I see the fraction 9/2. So we have to ask ourselves, how many halves how many wholes can we take out of that? How many 2/2 can we take? So if we count by twos, 2, 4, 6, 8, 10, 10 would be too many. So we can take 8/2 out of here, which would leave us with 1/2 left over. So let's go ahead and write that, express it as a sentence. So 9/2 is equal to 8/2 plus 1/2. Now the second sentence in this step is to rename the wholes. So 8 divided by 2 would give us 4. So that's 4 and 1/2. And then the last one is to put it together as 4 and 1/2. All right, so I'm going to pause my video. You're going to go ahead and try the next 2 questions on your own, and then we'll get back together and quickly review them. All right, let's check this work. So we can see over here on 32/7, I could take 28/7 out as my wholes and 4/7. And then I just showed my mathematical steps over here. On 24/9, you can see you could take 2 wholes out of it, and the leftover would be 6/9. And then you can see that I expressed that over here in these sentences. All right, let's quickly do the last thing together. And Maricela cut 4 equivalent lengths of ribbon, so equal lengths. Each was 5/8 of a yard long. How many yards of ribbon did she cut? So 5/8, 4 different times, right? So 4 times 5/8. Now remember, this is where we can think 4 times 5 apples. Remember, the unit is interchangeable. 5 times 4 is always going to be 20, but the unit is going to stay the same. So in this case, the unit was eighths. So we have 28ths. Well, can we leave that as 28ths? Well, it actually wants us to express it as a sum of a whole number and the remaining fractional units. So now this is where we're doing what we just did above. I'm just going to quickly think about a number bond. I can take 16/8, 2 wholes, and that would leave me with 4/8. Okay, so let me show that as express our answer, 28ths, as a sum of a whole number, which is 16/8 is 2, plus the extra 4/8, or 2 and 4/8. So we know that that's the answer now. So let's quickly write a statement. Maricela ribbon, or how many yards of ribbon did she cut? Maricela cut 2 and 4/8 yards of ribbon. Now, the one thing that they asked for us that I haven't done yet was to draw the number line, draw a number line to express, to represent the problem. So all you need to do, because I just want to see 4 groups of 5/8. So if we start here at 0, I know I need 4 more tick marks. 1, 2, 3, 4. And each one of these I can just count by 5/8. Let me change colors. So this would be 5/8. My second stop, 2 groups of 5/8 would be 10/8. My third group of 5/8 would be 15/8, and that last one would be 20/8. So we can show that 4 groups of them just by jumping up like this. To me, the number line is not the most important part of this word problem. It's all of the blue writing that I did. All right, so go ahead and attack that exit ticket, see what you do, and let me know if you have any questions. Great job.